So today, we're here to teach you geometry stuff. 8.5, chapter 8.5, section 8.5. We're here to teach you about the wonders of tangent, sine, cosine. As you see, my partner is writing on the board with horrible handwriting. But this is going to be section 8.5 of section 8.5, part 8.5.
Don't worry, everybody. You're going to learn all of this right here in a matter of 5 minutes.
All this, right? This right here, this and that, and all that.
Alright, I'm here to teach you how to do this equation. Simple, easy. Let's do it real quick. Alright, so tangent A would be the equation, sorry about my handwriting, opposite over adjacent. Now obviously, opposite to A right here would be this little a right here. So we're going to write little a right there. And then adjacent to A would be C. Just kidding, it would be B, because C is the hypotenuse. So A over B is the answer to number 1, tangent over A. Sine C, which is this bad boy right here. Alright, so sine C would be the obvious one, adjacent over the hypotenuse.
Frick. I put my finger.
We're doing this again. Technical difficulties. Back on sine C. We've been on that for a while now. So adjacent to C would be B, because A would not be, and that's the hypotenuse, right? So adjacent to sine C would be B, and the hypotenuse would be C, because you see this long leg? That's the hypotenuse. Answer, number 3. So cosine B right here, we're trying to find the adjacent one first. Adjacent over hypotenuse. So what we gotta do here is we gotta find the next one to it. So A would be the hypotenuse to B. So far we have A over nothing. But what would be the hypotenuse? C. Alright. C. Alright, we got that completiano. That's Spanish for complete. Alright, tangent B. Alright, that would be this one again. Sorry, I got a little confused right there. Tangent B. So we already know what tangent B would be. It'd be opposite. I hope you're getting this, camera guy. Over adjacent. So the opposite of B, what would it be? Little b. So we would have B over what? What's the adjacent to B? C? No, that's hypotenuse. Don't do C. Say. That's the examples we have today. Thank you for learning with me, Trevor Moulton.
I have a test tomorrow, and I gotta figure out what tangent, sine, and cosine means. What am I gonna do? What is this? SOHCAHTOA! Well, ladies and gentlemen, SOHCAHTOA means sine equals opposite and hypotenuse. Cosine equals adjacent and hypotenuse. Tangent equals opposite over adjacent. It kind of relates to all this. Because say I was trying to find the sine of, sine of A. I'd look for SOHCAHTOA. What does that equal? SOH. Opposite, which would be B, and then hypotenuse would be A. And then we would look for, something called cosine right there. That'd be CAH. What would that be? Cosine equals adjacent, so C over hypotenuse, A. And then the last one, tangent, my personal favorite, would be TOA. Tangent equals opposite, which is B, over adjacent, which is C. That's SOHCAHTOA for you. So next time you have a test, don't fret. SOHCAHTOA est.
Boom. We're here teaching you how to do this. Oh, goodness. So, first off, instead of finding everything, we gotta find this hypotenuse right here.
how do we do that? Chapter 1. Or like
Come on.
Section 1. If you don't remember that, that's a Pythagorean theorem. How does that go? Thanks for asking. So, a Pythagorean theorem is set up like this. That's the bell, lady. Alright, quickly cut that. Real quick. 8 squared plus 15 squared equals C. That's what we're trying to find. This is the hypotenuse. We're trying to find that. So 8 is 64. 8 squared is 64 plus 15 squared, which is 225. Sorry about my handwriting. It's up. Equals C. Now I'm just gonna move over here. Overall, it equals 289. Equals C squared. Now we have to square root it all. 289 equals C, square root of C, and 289 would equal 17. Usually it would be a lot like longer, but this is a perfect square. So thank you for the time. This is 17. Here at math, we don't be lazy. That's not my chair. Alright, so we are going to find out the tangent, sine, and cosine for our bad boy right here, A. So, tangent of A would obviously be the opposite over adjacent. So, what we're trying to find here is the opposite of A, which is 15. Then that came back 15. So, 15 over the adjacent. 17. JK, hypotenuse, that's 17. Our adjacent friend over here, 8. It's adjacent, obviously. So 8 over 15. You want to try leaving it this, because you don't want to have it as a mixed number. Mixed numbers are for children. We're not children anymore, people. Yeah. Alright, so let me just quickly erase that. Speed erasing. So now we're just trying to find the sine of B, sine A. Tricked you. So, sine A would be, on the top, it would be opposite over adjacent. Now, sine A, what would be the opposite? 15. Obviously, it would be 15, because I just said that before in tangent. 15, and then what's the hypotenuse?
Are you serious? Are you serious?
Hypotenuse. 17 is the hypotenuse. And then 15 is the opposite. So, my bad for that. So, that's what we have. So far we have 15 over 17 as the opposite over hypotenuse, which is 17. Alright, so we're going to move on to the cosine of A. Cosine. Okay. So, cosine is usually, you guessed it, opposite, I lied there, adjacent over hypotenuse. An adjacent of A would be 8 because it's not the hypotenuse and it's not opposite, so it's 8. Hypotenuse of A would be 17. So that's what we have for cosine. So let me just write it all up here. Cosine would be 8 over 17. Sine would be 15 over 17. And then our tangent friend over here.
We're going to apply what we have learned to a real life situation. So what we're trying to do is we're trying to find the height of this mini building. And so we are standing about 57 feet away, and we have to look 55 degrees up to see the top of the building. So we just draw this imaginary triangle. And so what we have to use is we have to use tangent to find the height of the building, as it's opposite and the adjacent leg. The opposite and the adjacent leg. And so we're looking at a 55-degree angle towards the top of the building. And so if we want to find the height, this would be the height right here. And so this is x. And to find the height, we can use tangent because this is the opposite and this is the adjacent line. So it'd be the tangent of 55 equals height, or, well, I'll just do this, make it easier, x over 57. And so height equals 57 times tangent of 55. And so we'll put that in our calculators and it comes out to height equals 81.4. And so the length of this, the height of the building is 81.4 feet. So to find these three trigonometric values, this is all you have to do. Your calculator has to be in degrees as indicated right here. Second, you have to press one of these buttons, whatever one you're trying to find. So if you're trying to find sine, you press sine, and it'll show up in your calculator as this. But it also depends on what type of calculator you have, so you're going to have to figure that one out for yourself. Then we'll just plug any value in. So we're going to do 79, close the parentheses, and the sine of 79 is 0.98. Do one more, and we'll do the cosine of 79 also. Just kidding. 79, here we go. This will be 0.19.
Make sure you have in degrees also. Oh, that's right.
Man, I hope I did good on that test. I wonder what I got.
Luther.
Oh, is this the test? Oh, I got 100. 100%. Maybe someday you can be like me and get hundreds on every single test, because I'm a smart kid. Who needs college? Mom? What do you think of me?
Thank you, buddy. Click bar. You forgot the You started too early.
The sine, cosine, and tangent for our bad bed. So you getting this, camera guy? Messed up right there. Sine is actually opposite over hypotenuse. Let's check about that.